Hello, I'm teacher Eda. So today we are going to learn about nuclear reaction. The learning outcome for this topic is 6.2 nuclear energy, and we are going to discuss about 6.2.1 communicate about nuclear reaction. First, nuclear fission, and second, nuclear fusion. What is nuclear energy? Nuclear energy is known as atomic energy that released during nuclear reaction such as radioactive decay, nuclear fission, and nuclear fusion. Nuclear energy is the energy in the nucleus or core of an atom. Nuclear energy can be used to create electricity, but it must first be released from the atom. Next, what is a nuclear fission? Nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Nuclear fissions of heavy elements was discovered on Monday, 19 December 1938 by German chemist Otto Hahn and his assistant Fritz Strassmann in cooperation with Austrian-Swedish physicist Lise Meitner. Hahn discovered that a captured neutron causes fission, a word they borrow from cell biology. It described the process when cells split apart. This shows a nuclear chain reaction. A chain reaction refers to a process in which neutrons released in fission produce an additional fission in at least one further nucleus. This nucleus in turn produces neutrons and the process repeats. The process may be controlled nuclear power or uncontrolled nuclear weapons. If each neutron releases two more neutrons, then the number of fissions doubles each generation. In that case, in 10 generations, there are 1024 fissions, and in 18 generations, about 6 times 10 to the power of 23 fissions. This picture shows a nuclear chain reaction. First picture shows the first generation and the second generation, third generation, and the last one is fourth generation of uranium atom and the neutron. If each neutron releases two more neutrons, then the number of fission double its generation. Like I said just now, in that case, in 10 generations, there are 1024 fissions, and in 18 generations, about 6 times 10 to the power of 23 fissions. A lot, right? Next, we are going to discuss about the example of nuclear fissions. Nuclear fissions are involving uranium-235 bombarded by a single neutron. For the first picture there, a uranium-235 nucleus is bombarded by a neutron and become an unstable uranium-236 nucleus is produced. And then the process produces a barium-141 nucleus, a krypton-62 nucleus, and 3 neutrons are produced. Energy is also released. The sum of the masses of these fragments is less than the original mass. This missing mass, about 0.1% of the original mass, has been converted into energy according to Einstein's equation. Fission can occur when a nucleus of a heavy atom captures a neutron, or it can happen spontaneously. This shows the nuclear fission involving uranium-235 bombarded by a single neutron. A single nucleus of uranium bombarded by a single neutron, you can see we get both barium and krypton that we call daughter nuclei along with 3 neutrons and energy. The atom of uranium will rarely undergo fission without first capturing a neutron. Now, we are going to discuss about nuclear fusion. Alright, the Sun is a main sequence star and thus generates its energy by nuclear fusion of hydrogen nuclei into helium. In its core, the Sun fuses 500 million metric tons of hydrogen each second. In 1920, Arthur Eddington proposed that nuclear fusion might explain the enormous energy output and longevity of stars. In 1939, Hans Bethe proposed a route of making helium from hydrogen elements that are known to be dominant in the Sun. What is actually nuclear fusion? Nuclear fusion is a two light nuclei combined to become a heavier nucleus and energy. This nuclear reaction happens under extremely high temperature and pressure. It sounds simple, but the condition needed to bring together positively charged nuclei and overcome mutual repulsion are extreme to say the least. Example of nuclear fusion is when a deuterium atom and a tritium atom fuse to produce helium-4, a process known as deuterium-tritium fusion. As shown, fusion of deuterium and tritium to give helium and a neutron releases an enormous amount of energy. In principle, nuclear fusion can produce much more energy than fission, but very high kinetic energy is required to overcome electrostatic repulsion between the positively charged nuclei and initiate the fusion reaction. The picture shows nuclear fusion between deuterium and tritium. Look at the positive charge on both nuclei of deuterium and tritium result in a large electrostatic energy barrier to fusion. This barrier can be overcome if one or both particles have sufficient kinetic energy to overcome the electrostatic repulsions, allowing the two nuclei to approach close enough for a fusion reaction to occur. The principle is similar to adding heat to increase the rate of chemical reaction. Fusion could generate 4 times more energy per kilogram of fuels than fission that is used in nuclear power plants and nearly 4 million times more energy than burning oil or coal. Most of the fusion reactor concepts under development will use a mixture of deuterium and tritium, a hydrogen atom that contain extra neutrons. In theory, with just a few grams of this reactant, it is possible to produce a terajoule of energy, which is approximately the energy one person in a developed country needs over 60 years. Now we are going to learn about the similarities between fission and fusion. Both nuclear fusion and nuclear fission use the energy stored in atomic particles in the energy production process. These particles use electric charge and other forces to stick together as an atom, unless energy is introduced from another source, in which case the atom can break up in the case of nuclear fission or join together in the case of nuclear fusion. When an atom changes itself during a nuclear reaction, it releases the energy that is previously used to hold the particles together or keep them apart. Next, both fission and fusion are processes that aim to produce energy. which power plants can then turn into electrical energy to power homes and businesses. It is the energy the atom releases as it changes into a different form that power plant harvests. Next, both fusion and fission reactions are suitable for making nuclear bombs. The atomic bomb of World War II were fission bombs, although the fusion bomb, also known as the hydrogen bomb, was tested only a decade or 2 years later. Next, both fission and fusion can occur naturally. The sun, the source of a heat and light energy for the planet, gives off energy produced by fusion reaction between like elements such as hydrogen and helium. Fission reactions do not happen naturally nowadays, but according to the Lawrence Berkeley National Laboratory at the University of California, about 2 billion years ago, a location in what is now West Africa was the site of a naturally occurring fission reactor. Next, we are going to learn about the differences between fission and fusion. Fission split a larger atom into two or more smaller ones, while fusion joins two or more lighter atoms into a larger ones. Fission most commonly use uranium and plutonium because they are easily to initiate and control, while fusion use deuterium tritium fuels because it reaches fusion condition at lower temperature and releases more energy. Fission byproduct is used nuclear fuel, while fusion byproduct is helium. Fission used in energy production, while fusion is still under development. Fission is 1 million times greater than other energy source, while fusion is 3 until 4 greater than fission. Alright, next we are going to discuss about the pros and cons of nuclear energy. Unlike traditional fossil fuels like coal, nuclear power does not produce greenhouse gas emission like methane and carbon dioxide. The cons of nuclear energy is, despite all the safety measures in place these nuclear plants, different factors caused them to go into meltdown, which was devastating for the environment and for local inhabitants who had to flee the affected area. Next, nuclear is non-intermittent, as nuclear power plants can run without any interruption for a year and more without interruption of maintenance, making it a more reliable source of energy. Cons of nuclear energy. One side effect of nuclear power is the amount of nuclear waste it produces. It has been estimated that the world produces some 34,000 meter per cube of nuclear waste each year, waste that takes years to degrade. Nuclear power plants are cheaper to run than their coal or gas rival. And for the cons, the initial costs for building a nuclear power plant are steep. A recent virtual test reactor in the US estimate rose from $3.5 billion to $6 billion, alongside huge extra costs to maintain the facility. So now, let's proceed to the question-related nuclear reaction. Question 1. What is nuclear physics? A. A field of physics focusing on the interaction of atomic nuclei and the particles that make them up. B. A field of physics focusing on the universe as a whole. C. A field of physics focusing on the smallest thing known to exist. And D. A field of physics focusing on the motion of macroscopic objects. The answer is A. A field of physics focusing on the interaction of atomic nuclei and the particles that make them up. Question 2. What is nuclear fission? The answer is nuclear fission is a nuclear reaction when a heavy nucleus splits into two or more lighter nuclei while releasing a large amount of energy. Question number 3. Explain the nuclear fission process of uranium-235. The answer is a single nucleus of uranium bombarded with a single neutron, producing both barium and krypton that we call daughter nuclei along with 3 neutrons and an energy. Question number 4. What is nuclear fusion? The answer is nuclear fusion is a nuclear reaction in which small and light nuclei fuse to form a heavier nucleus while releasing a massive amount of energy. Question number 5. Explain the nuclear fusion process between deuterium and tritium. The answer is fusion of deuterium and tritium producing helium, neutron and releases an enormous amount of energy. Okay, I think that's all for today. Thank you, class.